Good evening, or late afternoon, everybody. This is the last Edge Track session for the day, and after this, we can go party, all right? So, this one is about security. Security is on the top of mind of everybody, of Docker customers, Docker community, Docker ecosystem, and it's a hot topic. And we've assembled a very distinguished panel here to cover your questions and to cover the security ecosystem as well. Sean will be moderating this panel. So from here on, Sean, it's your show.
Thank you. Thank you for that handoff. Thanks, everyone, for being here for the last session of the day on what's been a busy and eventful day. I'm Sean Michael Kerner. I'm a senior editor at eWeek and Quinn Street. Usually security, as the introduction said, it's a top-of-mind topic. I see studies always after a security show where people will say, 85% of people think security is a barrier to the cloud or is really important or whatever. And I always wonder, who's the other 15% that aren't worried about cloud security, Because those are the people that I really should talk to because they know something I don't know. Anyway, we've got an esteemed panel here. We're going to do a couple of things. We're going to have some brief introductions just to give you an agenda. We're going to talk about what users need to know at a basic level, then we'll get into a little bit more detail. We'll talk about war stories. Not that any of us have been in a war, so we should never say that necessarily, but breaches, security incidents, things that have happened, because that always happen. We've got different vendors, so we'll talk about the vendors, the opportunities and tools, and then we'll finish up with what's next. And by all means, I'm hoping this to be as interactive a panel as possible, both amongst panelists and the audience. So if you've got questions, by all means, if you want to ping me on Twitter, I'm at TechJournalist, and I'm checking, and we will do questions that way or in the audience. To my right, I've got Nathan McCauley from Docker. We've got Liz Rice from Aqua, Wave from StackRox, Steve from HPE, and John from Twistlock. And if you guys can just go down the row and just give a 2-second overview of who you are and what you do in your day job.
Sure. So I'm Nathan. I have the distinct privilege of managing the security team at Docker. At Docker, we make this container runtime.
I think I've heard of it, yeah. So I'm Liz. My job title is Technology Evangelist with Aqua Security, and my background is much more development and engineering than it is security, so I'm kind of coming with that perspective, but working for a company that specializes in security.
My name's Wei Lian Deng. I'm VP of Product at StackRox. StackRox secures enterprise container environments with a platform based on microservices and machine learning. My background's primarily in security, virtualization, and distributed systems.
My name is Simon Leach. I'm a Chief Technologist at Hewlett-Packard Enterprise in the Digital Transformations team. And my background is security, and I try to help our customers understand what they need to do to secure their application transformations.
I'm John Morello. I'm the CTO for Twistlock. I was a Fortune 500 CISO before Twistlock, and then at Microsoft for many years before that doing security stuff.
Fantastic. Well, thanks, everyone. And then just so that I'm clear, I know that there are some Docker security people front row. I don't know if Nathan's told you had to show up, but that's great. I'm just curious, how many people would consider themselves in the audience to be security people? A few. How many people just developers, non-security related things? And then how many people are just kind of in between and trying to figure out what security is all about and what Docker development is all about? We got a few, which is great. So hopefully we have a good mix here. So just as the easy softball, because I'm at that layperson kind of thing. I've used Docker. I use it regularly for different kinds of things. So I've deployed Docker for my basic Minecraft servers, whatever. I'm using the basic Docker tools. What am I doing wrong, Nathan? We'll start with you. To not properly secure Minecraft so that evil hacker doesn't go in and do bad things to the creepers.
So the first thing I'd ask is, are you checking for CVEs in the Minecraft server? Do you have a security scanning solution?
Okay, probably not.
Probably not. Oh, you don't want to answer. That's fine. Okay. So I'd say
don't look for my Minecraft
far and
server,
away
please.
The highest leverage thing that anyone can be doing is making sure they aren't deploying known bad code. Yeah. So that is hugely important. So I'll start there and just say you must be doing that. You must be looking at what you're deploying and making sure that it comes from a good source and that it is free of known vulnerabilities. Everything else kind of is an add-on to that, but that's really a foundation that you need to start with.
And then Liz, just from an Aqua perspective, what am I, if I did everything that Nathan said, and I'm doing everything that Docker tells me, what still should I be doing that perhaps your company would be offering me to protect that unprotected Minecraft server?
Sure. So, I mean, there's a few things. I'm going to just put one in so that I leave some space for other panelists. I'm going to say managing your secrets, and in particular, making sure you're not putting secrets in your container images, that you are passing them live into those containers. Ideally, they're encrypted as they're passing to your containers, and you're only passing them into the containers that need those secrets. Things like database passwords and keys, that kind of thing.
Yeah, so what would I be getting from StackRox? What kind of additional things are you providing beyond what I'm getting Docker native?
Yeah, Sean, so I'd say you'd start by looking at what the platforms provide. And I think they've done a great job of building in a lot of capabilities around vulnerability scanning, image signing, secrets management, and so forth across the CI/CD pipeline. And what you need to complement those capabilities are actually functionality that enable you to achieve detection and response. Meaning being able to actually detect on intrusions and active compromise, because we all know that prevention and hardening is not sufficient by itself. And so you actually need the ability for security teams to actually be able to triage, investigate, and root cause instance within the environment. And those are the types of workflows that StackRox assists customers with.
And then from an HB perspective, when you're talking to customers about Docker deployments, do they bring up, or do you bring up, certain security best practices that you recommend?
Yeah, so definitely. I mean, it's always the number one question that our customers have when we talk with them about application transformations and how are they going to take their legacy apps and put them into a container-based environment. And I'd say that a lot of the tools that are available, and specifically within Docker itself, and Docker's made some great improvements around the security infrastructure that they can offer, but there's still a little bit of a way to go in terms of providing stuff outside of the CI/CD. So things like the real-time or runtime application protection, but also below that. So extending the concept of containerization also into the kernel, and look at things like the okernel project that's been developed as part of Moby project and Linux kit, and see how that can help improve the security. And then, of course, not to forget about the physical infrastructure that it's already running on as well, and making sure that you've looked at how that can add to your overall security story. Yeah, absolutely. Physical infrastructure is important. That's the standard joke in my line of work about cloud is really just another person's server, right? And then, John, from a StackRox perspective, what should I be doing? What do I need to know?
I probably won't comment on StackRox, but I will say with Twistlock.
Well, you could. We'll talk. We'll do.
It depends how testy you want this to be.
We'll do that after, and then we'll get the arm wrestling into.
Now, I would say, everybody's comments were absolutely good. I mean, I agree with all of them, and frankly, that's why we have all those same capabilities in our product too. I mean, I think it's pretty clear the set of things that people need to prioritize. I would say one other thing that wasn't pointed out that I think is equally important to the technical capabilities, though, is usability and integratability, I guess, with existing systems customers already have. I mean, if you go to any large organization, they're going to have probably millions of dollars worth of security shelfware, things that they bought but they couldn't deploy, that they were just too hard to use, too hard to integrate with. One thing that we've really focused on is to make sure that everything that we do is accessible both to developers from an API standpoint, very easy to use, very easy to integrate to their processes, but also really easy to integrate with existing security tools, whatever your SIM is, whatever your existing dashboarding tools are, so that when you see those alerts from a runtime perspective or problems related to vulnerabilities in your images, you're seeing that in the same dashboards, the same ticketing systems, and you can dispatch that work in a way that's really integrated with what you already have.
And then just to follow on that thought, is container security a unique discipline, or do you think it should be for a security analyst to be specifically trained in container security and the SOC to have specific processes and flowcharts to deal with container security as opposed to hardware or other infrastructure or other software?
Obviously there's some technical differences to containers and the way that containers isolate applications and the way that you deploy and operate them and so forth. So there's obviously a body of knowledge that is container specific. I very much believe, though, that securing containers and applications that run in containers and microservices is still fundamentally the same security discipline that we've had for years. Like, you don't need to figure out like a new book to use. You don't need to figure out completely new approaches. The same things that everybody has said are best practices, least privileges, defense in depth, all those same concepts are equally applicable to containers. So the way I think most of us here would probably agree even is that if you believe that kind of the future for application delivery and operation is containers versus, kind of bare metal or VMs, then it's not a matter of like having container specific people. It's about getting all your existing people aware of those things that are unique about containers and getting them prepared to secure them.
One thing I might just add to that, and it is really an addition. I have no interest in disagreeing with John, but one area where I would say that it makes sense to train the security engineers around containers specifically is there have been many best practices that we've been talking about for the last 20, 30 years. There are ways that containers actually make some of those best practices realistically executable, where things that was generally agreed upon as a best practice, but no one could really do it because it was too hard. There are certain aspects of containers that make that possible. For example, being able to deploy very often. Having the infrastructure agility to be able to update your code very frequently means that there's a fundamentally better way to push out updates. Another way we see that is just the microservices movement. If you do microservices right, you end up with a least privileged infrastructure because any particular executable that's running within your infrastructure has a far more constrained set of privileges necessarily because it doesn't need to call all the APIs. It doesn't need to access all the data stores. So a move to microservices and a move to containerize your apps can really help there. So I think there are gains that you can get from kind of teaching your security engineers and your engineers at large about some of these concepts.
And I think I'd add to that as well. At the end of the day, it's about integrating good security hygiene overall. Because if you look at a lot of the major breaches, there's really one of two reasons they happened. Either it was a user error, and you can't fix stupid, unfortunately, even if you're using containers. And the other one was down to a vulnerability in an application that hadn't been patched. And containers definitely give you a lot of capabilities to refresh your golden images, to update the applications to make sure they're not vulnerable. But if we have security hygiene sorted out from the beginning and we start to think about shifting left from a security perspective and integrating code analysis when we're developing the code to try and reduce the number of vulnerabilities that go out of the door, i.e. make security a gate process when we're developing applications, then we end up with a much more secure platform that we can start from. And that's where containers can help, as Nathan said.
I think there is actually a bit of a change of mindset that containers allow us to take, and cloud native in general. This idea of immutability that is kind of best practices for containers and best practices for infrastructure as code. We do need to train people to think about their deployments in that way, to think about them as being immutable, to think about, you mentioned the golden image and the reverse uptime principle that Diogo was just talking about. I think that's really important, the idea that you really are deploying immutable entities and you are not patching things manually, and you're doing a lot of this in an automated fashion, which is a change of mindset.
I think the additional theme behind this is that containers as a technology actually allow for and enable better scalability and automation as well. So if you're comparing it to a traditional SecOps or security operations or responder perspective, there's a lot less that you'd hope that a person would actually have to deal with. And I think on the topic of immutability, I think in terms of best practices, in terms of how you actually approach security, the minimal and atomic nature of these components actually allows you to take fundamentally new approaches to actually how security is architected. You can derive better understanding of application behavior. You can better pinpoint indicators of attack and compromise within your environment that can ultimately inform how you actually approach and improve both prevention and hardening.
Now, all that said, I've heard from various peoples that are still not on the microservices container bandwagon that there are challenges with policy. So we've got all these great policies. You can do, immutable containers, you can do isolation, segmentation, namespace, everything else. But where does policy exist? There's RBAC inside of, Docker Enterprise, there's RBAC inside of Kubernetes. Many organizations that I audit or visit will use Active Directory as their source of truth. It's not a good source of truth. If you're a Microsoft person, great. But so when we talk about a microservices container deployment, and we're looking at policies and the potential for policy confusion, where is that source of truth? Where should it be? Should it be with Docker at the container layer? Should it be somewhere else? And in your opinion and your expertise, is there a potential for confusion there such that it renders the entire end-to-end security at risk? Don't all jump.
I'll take a first stab. I think there's going to be a good amount of opinions here, but I think that the most effective policy is the one that compiles. If your policy compiles, that means that it was declaratively written by someone who had an ability to make a decision. So the highest leverage policies are those that show up in development artifacts, say from a developer saying, hey, look, I know because I understand these three containers that these three containers only need to talk to each other, and then if that is derived from, say, a compose file, then that's because it's been left shifted in the process, you have the possibility for a very simple policy that can then translate into a runtime policy and configuration. So the policy level kind of at like container to container and what the containers are doing is best solved by developers and is in that scenario best solved by things that compile. I think we end up with a different question when we start talking about what kinds of actions are admins allowed to take in a cluster, where you necessarily have some rules that shift with organizations. And so because they shift with organizations, there's fundamentally a need to be able to update those and rely on sources of truth. So I'll let some other folks talk about their opinions.
I was going to throw in, well, which kind of policy are we talking about? You know, there's policies around, which images you're allowed to admit. There's policies around what your images should consist of, the base images, what vulnerabilities they're allowed to deploy. Then there's a completely different set of policies around runtime profiling and what your runtime behavior should be. And then there's the whole role-based access control around administrative actions and who is allowed to do what, where actually to John's point earlier on about integration points, if there is a source of truth in an organization around who people are and who teams are and what they're allowed to do, use that as the source of truth for those RBAC controls. Why not? That's a sensible integration.
Yeah, I would say one of the challenges that you have with the space is that it's not just the images, not just the container runtime. You have the host, you have the daemon configuration, you have the orchestrator. If you do a great job, and I don't at all dispute what Nathan's saying, if you do a great job in developing your applications and creating a compose file and so forth that describes it, that's awesome. But it doesn't really help you if the underlying host is configured poorly or the daemon's not secure or whatever. And so I think when you think about policies and sort of like configuration control, there's something you have to look at throughout the entirety of the stack versus just a particular slice of it. Yeah. And part of that is like, what are really the best practices? We've got a lot of great stuff out there, and like the CIS benchmarks for Docker. There's Run Now for Kubernetes. There's the NIST special publication that came out recently. So I think a lot of the technical content is out there, and there's value to people. Obviously, it's self-serving. There's value in people, I think, when you have a platform that you can use to help enforce that across the layers of the stack, because you have a better visibility and a better ability to create that policy one time and apply it everywhere.
Just to add to that as well, I mean, I think it's great to have a set of policies in place when you're talking specifically about the container environment and the stack that supports that. But it's also really important to get the buy-in from senior management as well. So if you're going to move towards a container strategy, make sure that senior management is aware of the potential risk that could be introduced or could be mitigated on the other hand, and that they can start to view that from the perspective of the overall organizational security goals, and how is moving towards containers and moving towards agile applications really going to support that. And that becomes especially relevant when you start to look at some of the certification or some of the standards that organizations are having to comply to, things like GDPR, some of the local regulations in EMEA, which really make security very, very key and a board-level topic and discussion.
I would just add that I think policies start to look very different based on the relevant stakeholder. I think from the perspective of a DevOps or application team, you care about declaratively saying what an application should or should not do. and that impacts the build and deploy process. I think at runtime, security professionals, security teams, operators, and responders are going to care about certain policies and certain actions that you may or may not actually want taken within your container environment, depending on what you've potentially detected or what's actually going on with the application.
Yeah, it makes sense. There never seems to be there's an endless amount of studies that I see, and usually they'll always say that there's too many privileged accounts out there, that people have too many, and 8 out of 10 breaches that I read about is always due to some kind of privilege escalation, so that's always a risk. And then just going on to a slightly different topic, or slightly have to step to the side. When you see customer engagements or otherwise, what do you think, and I'll start with you, John, we'll go back this way, is the most overlooked piece of container security when you're meeting a customer for the first time? Is it something like when Nathan was just saying, they didn't look for the CVEs, or is it something else?
I mean, the CVE stuff, I think, is generally well accepted. And it's fairly obvious, right? There's lots of tooling that you can use to find vulnerabilities in images and so forth. And I think people generally recognize that. I would say that the most overlooked part is really the operational aspects of it, which kind of gets back to your previous question, which is, it's easy to find images that have vulnerabilities, but even if you mitigate those vulnerabilities, if the applications within them have, weak default passwords or something, or, they're configured poorly or whatever else, and it doesn't really help you if the image itself might have vulnerabilities if you can just access and attack the application directly with an authenticated bypass sort of scenario. And so I think that aspect of it is probably the most challenging thing and the most overlooked thing to people, because there's also kind of this notion that if I've containerized something, or if I virtualized something, that somehow I've done something to help secure it. Well, you've given yourself the ability to secure it more effectively. The act of actually containerizing it directly doesn't do anything to actually improve the security of it. It just gives you the options to do things later on. And so I think the complexity that's there, and the fact that people have a lot of sins of the past, that they're just kind of lifting and shifting into containers just as they did into cloud and into virtualization before it, is probably the biggest risk that most people have. It's not something specific to containers. It's the nature of just people having poor IT operational practices.
So I think I'm going to go for a non-technical concern, and that's really about developer education. So especially when we look at agile app development and containers, we're now expecting the developers to be security aware, because we're taking a lot of the security controls out of the infrastructure team and handing it back to the guys that are actually writing the code. And there are very few developers today that have got the security experience to develop applications securely. So I think it's really important that you invest in those development teams, make sure they're getting the appropriate security education, make sure they're aware of the type of tools that can be used to support their code writing, and really just give them a little bit of a head start, because you're investing in them. It'll make them happier. It will make them more productive in the long term. And although expecting them to start to integrate security best practices is going to add a little bit more time to the development life cycles, it's going to reduce the time afterwards when they're going to otherwise be spending fixing vulnerabilities or fixing problems they've caused. And I always look back to some research that was done by Carnegie Mellon University, where they look at the amount of errors that coders introduce into their code. And on average, coders make 40 errors in every 1,000 lines of code. Now, not every one of those are going to be security errors, of course. It will be spelling mistakes, or using the wrong variables or the wrong colors or whatever in the GUIs. But some of them will definitely lead to security errors. And the more of those mistakes you can fix before the code gets compiled and before the code gets put into production, the better your development team is going to feel, because they're not getting hassled as they identify these problems with the code they've written. So developer education from a security perspective, I think, is really important.
There are two main areas that I often see overlooked by customers, at least today. So the first actually is runtime security as a whole, which is, I think, there are a lot of customers that I come across who think if they implement vulnerability scanning, that's enough. And I can tell you that every customer I've come across is running vulnerable apps and containers, because even if you're securing or hardening your container infrastructure, you can still run vulnerable code in it. The second I see actually often overlooked is the orchestrator as a separate and distinct attack surface. I think people do not necessarily immediately realize that a lot of the orchestrator services themselves are containerized, and that the orchestrators actually assume that administrators are authenticated personnel, and they don't guard against the case where you have an RCE on a laptop, or compromise or other unauthorized access, which can actually allow for some highly privileged actions to be taken on the cluster.
So if I was going to pick a feature that I think is often overlooked, it would be around user namespacing and the fact that people very rarely use user namespace mapping, and B, they're often running as root inside a container. But I'm going to come back to the thing about vulnerability scanning, just because I think it is one thing for everybody to accept that, yes, vulnerability scanning is an extremely important part of our security process, and customers do that. It's very important. But it's also critical that the results that come out of that vulnerability scanning are, they're not full of false positives, and that they're readable and actionable, and, you haven't got 300 pre-existing warnings that you've been ignoring for 6 months, and inside that forest of issues, you don't spot the one new really important thing that's changed. So while I think we're all aware that vulnerability scanning is important, the usability of those results is extremely key.
I think there was a lot covered there.
That's good. Because we've got about 10 minutes left, and then we'll get to questions. How many people in the audience, I hope everyone is still with us, how many people in the audience have had a breach in their container that they want to admit? Nobody? Okay, good. Good job. Nobody ever wants to admit it, and I got to tell you, I've never actually reported on one because nobody actually discloses that. Nobody tells you when there's a breach that it was inside of VMware, unless it was a VMware hypervisor escape at Pwn to Own. But just in the war stories bit, if anyone wants to chime in about any exploits without naming names, because this is being recorded, where you've actually seen an exploit in a container system, whether it was a result of bad policies or CVs or otherwise.
Yeah, I'll start. And I was actually talking to Nathan about this the other day because some of our joint customers are concerned about particular attacks, and I think it reflects the fact that the threat landscape is still emerging and it's not well defined. And to share, we actually recently had a customer that had an incident, and the attack pattern, interestingly enough, reflected a new type of threat vector. And what we saw was a code injection on a web-facing service, followed by lateral movement to an internal containerized brokerage service. This was a large bank that we were working with, followed by movement to a DB service and data exfiltration. And the indicators, for instance, that we look for across the entire threat pattern are things like malformed content to anomalous network communication to sensitive file system access, outsized HTTP payloads. And the idea is that you actually have to understand that set of different threat indicators across the entire vector to actually understand what's going on. And so from my standpoint, I think it continues to be a threat landscape that needs to be better well understood, and I think there needs to be more research and investigation into what are the different types of threats that can arise, because I think as sensitive assets move into containerized environments, they become increasingly attractive targets for attackers and threat actors.
So I kind of had to ask around the team about this because I was suddenly aware that, actually, I talk about, security and threats sort of in the abstract quite a lot, but I didn't really know, what have we seen in the field? What's actually happened? And a couple of stories came back. One was finding resources being used for Bitcoin mining. Apparently, we have detected that for customers. And the other is kind of following on from my previous point, where my CTO was telling a story about showing vulnerability scan results to a customer and a developer basically looking horrified and then running out of the room, like literally running out of the room to go and fix it.
Yeah, I think that what I find interesting about a bunch of these cases, and all the cases that I've heard, for example, we have like everyone, we have a security @ email address where people can submit issues that they find on our website and on our service. And in all the cases that happen, none of the exploits have anything to do with containers. The exploits always have something to do with the application that's running inside the container. And so that I've never heard yet something that was specifically about the container versus being something about the application that's running in the container. And actually, the counterfactual that I have heard is when someone gets RCE in a service, because RCE is a pretty common problem that you could have in an application, the container boundary actually does help contain that application. At least gives you there's this concept that's called dwell time. And the idea of dwell time is how long does an attacker need to be in your infrastructure in order to achieve exfiltration, because their goal is to get some data out. And if you can increase dwell time that it takes, then you have a better chance to detect and respond. And what I find very interesting is that for many of the folks on stage, the thing that ends up being very useful about their service is that as Docker increases dwell time, because you have to do lateral movement to actually get to something interesting, that gives a chance for detection strategies to detect people and get to that remediation before anything bad happens. So that's one of my sources of great happiness in this space is that there's so many people working on that detection phase, because that's really what's going to help a lot of customers in this area.
Now, because there are so many people in the space, and there is room for confusion, are there too many security vendors in the Docker space? And I know we've got 3 security vendors here. So 3 is a good number.
3 is the exact right number, right?
But in the traditional security space, there's 100. You go to RSA, you get 400. 380 are doing exactly the same thing. Is the number okay, or is there enough to grow the pie? And then, just as a supplemental to that, how are you guys differentiating? Because some of the things we're hearing here are the same. Some of the things I write about are the same. But
so I'll start this by saying I think there can never be too many security solutions if they're solving the right problems. But I think what you see at the moment, if you look at all of the security vendors in this particular space, and there are 3 on stage, 4 if we include Docker, and a number of others as well, they're all focusing around maybe 4 or 5 different areas. And I don't think there's one vendor that covers all 5 areas yet today. So what I would hope as more vendors come into the space and as the vendors come out with newer and better solutions is that they kind of learn from one another and they use that to challenge one another. And we therefore see a lot faster development. And we've seen that in the past where if you're the only vendor in the space, you've got no real reason to develop fast or to innovate fast. But when you've got a lot of competition, and bearing in mind that all of these vendors are, well, I think most of them are still pre-IPO, they've got very good reasons to be successful in their space. So I think having a number of vendors is going to allow them to innovate a lot faster, or it's going to force them to innovate a lot faster. And I think that's going to help in the long term. But at a certain point, we're going to start to see acquisitions in the space, and some of the bigger, more traditional security vendors are going to have to buy into the container security market to keep present, to keep relevant. So we'll have to see what happens in time.
Yeah, I mean, I think the idea of having competitions, I believe in free markets, and the idea of people finding solutions and finding the right solution based on what customers tell them by buying is really the best way to shake that stuff out. And certainly we all learn from each other and see what others do. And I'm sure people learn from what we do as well. In terms of differentiation that you asked about, I would say, like, for us at least, like, we believe in sort of 2 things as real differentiators for us. One of them, to your point, actually, is the completeness of the platform. And I often talk about the fact that for us, we really think that that the strength of the wolf is the pack, and the strength of the pack is the wolf. The fact that we want to have all the capabilities in an integrated solution that works well in your existing environment: vulnerability management, compliance, runtime, network firewalling, all that stuff in one. And the other thing is just the automation that we provide, the fact that we're able to, without any kind of learning mode or manual interaction or supervision, be able to develop a very comprehensive model of what your applications do, how they interact with each other, and to use that known good baseline as a way to hunt for anomalies versus having to have signatures or other kind of threat indicators added. So that's the approach that we take. I'm sure there's others that have similar approaches, but that's our philosophy.
I mean, absolutely, competition is a good thing, right? If there were only one vendor here, we would probably, it would be indicative that we weren't really addressing a good market. So, having competition is fundamentally a good thing. And, there's quite a lot of money in this space from, investors. We recently got quite a big round, and I know there's been some other companies in the space who have raised recently. So there's clearly, perceived value that we're, as a sort of collection of vendors, creating through these products. In terms of differentiation, I mean, I think everything John said about learning from each other is absolutely true. In my mind, I've sort of remembered our tagline of securing once and running everywhere. So being able to integrate your Aqua secured deployment with whatever tools you're running with. But if you then want to move to a different cloud provider or a different orchestrator, you you can take your security solution with you. And obviously, I would also question the thing about completeness, but we can agree to differ on that.
So I think there are actually too many vendors. And I think it's because there are too many that actually overlap and compete with what the platforms do. And I think that customers should actually ask, what should I look to my platform to provide? And what should I look to standalone security vendors to provide? And from a standalone security vendor perspective, I think that we need to be focused on solving the deep, complex problems that security professionals and security teams are focused on. So, one aspect of how we differentiate is we focus on CISOs and security operations teams and enabling those professionals to do their jobs and prevent attacks and different threat vectors and such. And so I think that it's a question of where should standalone vendors focus, and I think that the opportunities lie in where we can go really deep, while the platforms are going to provide high value around going broad across the build and deploy phases of the lifecycle, for instance. And I think there are some very challenging problems from a security angle to be solved at runtime.
Makes sense. And then just to be mindful of time, we have about 5 minutes left. So if anyone has any questions, do we have a mic? Any questions? No questions? No questions. We got 2 questions at the back. Do we have a mic? We got the mic just right up there. So just ask away.
Hello. I'm a security engineer, and 90% of my problems aren't technical. So how do you sell security to both engineers and management? How do you make them care about dedicating time to making things secure?
Would you say 90% of your time is spent on?
90% of my time is spent on implementing technical policy and educating developers. But how do you bring security practices on a grassroots level to both engineers and management?
Okay, so I can start on that one, I think. I think one of the things that I'm seeing with customers today, and I guess everyone in the room that deals with EU customers has heard of GDPR, right? And GDPR, the General Data Protection Regulations, that's really allowed companies or allowed security teams to raise the importance of security with the board level, because at the end of the day, there's nothing that motivates a board better than avoiding a fine or avoiding a financial penalty. And although something like GDPR is completely non-prescriptive, meaning there aren't any specific technical security controls that need to be implemented to get GDPR certified, as it were, what it does ask for is state-of-the-art security. And one of the areas that you can use that is really just to free up budget, to open up the wallets a little bit, get money to create and make your own security program a little bit mature. And one of the areas that does make a lot of sense in is when you start to talk about things like application transformation and infrastructure modernization, because you start to see things like the recent WannaCry ransomware attacks. What organizations did that hit? It was the organizations that hadn't refreshed operating systems, that hadn't updated applications. And if you start to go through a transformation exercise with those groups, start to get them to invest in things like application modernization, that by default means they'll have to start looking at new infrastructure, they'll have to start looking at new operating environments, and that really starts to get security to the front of the table. So use the regulations that are out there to your advantage. We have seen, though, that compliance has often become a bit of a tick box exercise with customers. So make sure you don't fall into the trap where you get certified and then you forget all about it. Use the certification budget to create a longer lasting security program that you can use and you can reuse as time goes by.
I would echo that kind of there's like a baseline level that must be achieved with compliance, but the problem with compliance is that you need to be compliant and not an ounce more. An ounce more compliance is a waste of money. So what you need to do is find a way to basically, you want to find a way to get infinite headcount and be hyper effective within your organization. And the best way to do that is to have all of your security engineers be engineers that are embedded into other teams. So read up on Peter Drucker and matrix style organizations. If management perceives the security team as a cost center, you've lost. What you want to be perceived as is a profit center. And so if you're constantly embedded into other teams and contributing to their objectives, then the way your security team will be set up is you'll be able to get infinite headcount And if you pull that off, you'll be able to have a hyper-effective team like the Docker security team.
There you go. Got the Docker plug. We probably have time for one more question if anyone's got a question.
I think one of the issues when trying to figure out what you start with, there's so many things to do with security, is to understand what the threat landscape is. You've mentioned a few things, but what should we be most worried about and trying to prevent?
One thing I would say is, as we've discussed earlier, the threats here are really not like container-specific threats. And I think people have gotten really wrapped up, in a lot of ways, sort of because of the way it's written about in the press, no offense, and to you specifically.
If it bleeds, it leads.
Yeah.
That's the way it works in my line of work. And it's always Russia or North Korea.
Yeah. But the problem with that, though, is like people have gotten this mindset that like there's like a special class of container-specific attacks. Like, do those exist? Sure. Like you can see the occasional thing at a conference about something about a container escape, but like no different than it was with hypervisors and so forth in the past. The things that you should be worried about today with containers are almost exactly the same things that you should have been worried about a year ago or 5 years before that or 5 years before that. It's about, in a lot of ways, doing the fundamental security best practices that everybody knows they should do, but they don't actually follow through or they don't have the organizational support to do. It's about making sure that you stay up to date. It's about having the least privileges and all the kinds of things that you normally are doing versus saying like, oh, there's some really weird esoteric attack that's specific to containers. And not to say that that won't ever exist, but for the 99% of people that are out there, you're much more likely to fall victim to somebody having a bad password or a misconfigured VM or a misconfigured app in their container than you are something weird that's going to give you a container escape scenario.
I think that's totally true. And Simon referred to things like WannaCry and a lot of the sort of famous, newsworthy exploits that have happened recently have all basically been about people not having patched their code, not having up-to-date code. As John says, nothing really to do with containers. But, if you do one thing, it's keep your code up to date. That's kind of the fundamental thing. I saw a kind of statement from Gartner that says that zero-day vulnerabilities account for, or will account for, 0.1% of exploits up to 2020 or something like that, which, so that isn't really what we need to be worried about. What we need to be worried about are the existing known things that we could be, patching. The fixes exist. It's having good processes and the support to get those good processes in place.
Some of the specific threats that we've seen, and which are sort of common across environments that you may want to think about, include things like code injection, privilege escalation, reverse shells, common web-based attacks. And while those are not specific to container environments, I think the way you actually are able to detect on them and actually deal with them have to change in container environments, because you're dealing with stateless applications. When the container is gone, how do you actually do a proper response and forensics investigation on it? And so there's a bunch of considerations that actually change how you actually have to operationalize security in a container environment for those threats. But those are some of the common ones that that we see, and which are ones to perhaps have top of mind.
I'd say my view on this is that the biggest threat to be considering right now is settling for good enough. Right now, containers are already like a huge win for security, and a lot of the stuff that the folks are providing here, have you end up with a infrastructure that is fundamentally more secure than has really ever been possible. But I still feel like we're in the infancy of this space. There's amazing stuff that is happening now and is still possible. So when we talk about like completeness of the platform, I think we're not even close to what is possible in terms of things like microsegmentation of container-to-container communications, some of the stuff that HP is doing with okernel. Like, there is a lot of really good stuff that's left. So the biggest threat to the ecosystem is you all not having ridiculous expectations on us, because there is a ton of stuff that is possible, and if we build all of the stuff that needs to get built, we're going to end up with a really, really, really secure platform, and we should do it.
That's fantastic. It's a good place to end, and we're out of time, I think. We're out of time. So next step is the party. Thanks to everyone for coming, and hopefully you learned something so you can go back to your organizations and be safer, so that if we do this panel again next year and I say, has anyone been breached, we'll still get no hands. And thanks to everyone, to all the panelists for being on the panel. Thank you.